Hi, my name is Steve Ward. I'm Consultant Application Engineer at GE Intelligent Platforms, and I'm here to talk to you about Series 9030 to PACSystems RX3i migration. GE Intelligent Platforms Series 9030 controller was first introduced in 1990. Major features were that it was based on 16-bit Intel processors. It had a high speed, at the time, serial backplane. With the latest generation of CPUs, we have a high-speed logic execution of 0.15 milliseconds per K and a relatively large memory of 240 kilobytes. Relatively large, at least for a third-generation machine, which is what this is. Now, the Series 9030 has been extremely successful. We've sold over 700,000 units of these worldwide, and it's probably the most popular shoebox-style CPU. 21 years is a long time. And in 2004, we introduced the RX3i. The RX3i had several major new features, such as a layered design based on standards. So we moved away from 16-bit Intel processors towards 32-bit Intel processors. The latest revolution of that is to use COM-Express boards, which isolates us from the latest manufacturing cycles for CPU chips. So whereas companies like Intel and AMD now typically only manufacture a chip for about 5 years, with COM-Express, we have a door-to-board arrangement where we can migrate to new chips much faster without having to redesign the entire board. And the latest range of processors we have use a COM-Express board with a 1.1 GHz Atom processor, and then that also includes embedded Ethernet and other functions. And we have control of those COM-Express boards as we're a manufacturer via our embedded team. So as standards evolve and as new processors come along, we're able to move forward with those very easily. Other benefits of the RX3i include a PCI backplane, but we still preserve the serial backplane, which gives us a very straightforward migration capability because existing modules can be reused. Because we've gone to faster processors, we have faster logic execution with now 0.05 milliseconds per K. And in some cases, logic execution will even be faster than that because we have a much faster base processor, so features that don't use the Boolean processor can run even faster. We've also increased the maximum memory, whereas we were talking about 240 kilobytes, now we can go up to 64 megabytes. And even the entry-level CPU has 5 megabytes of memory, which will be more than enough for most small to medium-sized applications. Now, moving forward with new technology, we've also introduced additional features with the RX3i. These include symbolic programming, so you don't need to map any variables to data tables anymore. Instead, you define your variable, you give it a name, and that's all you need to do. So this means it's much easier to reuse code, it's much easier to write applications because you're not worried about overwriting other people's data tables. It's much easier for multi-programmer teams. So symbolic programming makes things a lot more straightforward. We can also move to object-oriented programming with user-defined function blocks. This allows you to develop core function blocks which do your common routines such as pumps, valves, motors, sequences. And then once you've defined that block once, you can put that into the tool chest library and then you can reuse it in future. So you can share it with colleagues, you can reduce the overall time it takes to generate your applications, and then it's very straightforward using your object-oriented programming to move forward and have less programming effort as time goes by. A major feature of the RX3i is that the program and documentation is stored in the controller. So when you download, as well as just downloading the program, all of the variables, all of the run comments, all of the related documentation, including things like Word files, AutoCAD files, Excel files, they're all included. So this makes it very straightforward for you when you go to site to just upload your program into the Machine Edition software, and then you know that you have all of the latest program and documentation without having to worry about finding backups, worrying that you might be missing data, worrying that you don't have the latest up-to-date version. Because it's all stored in the CPU, you know you will have the latest copy of the software. RX3i is also a platform for future development. We've recently launched Profinet controller and scanner modules, and it will also be a future development for embedded PCs, advanced I/O, and other developments as we move forward in the future. Of course, there are lots of those existing Series 9030 still in the field, so as GE, we've made it very straightforward to migrate from existing Series 9030s up to the latest generation RX3i controller. From a hardware point of view, it's very straightforward. You just replace the existing Series 9030 rack, power supply and CPU with a new RX3i rack, power supply and CPU. You keep the existing I/O modules and field wiring. Because we're using two backplanes on the RX3i, we have the new PCI backplane for new modules, but we have the old Series 9030 backplane. This means existing I/O modules can be plugged straight into the backplane without needing to be replaced. So your existing I/O modules, along with the existing field wiring, can all be preserved. And in our experience, field wiring, this is one of the major expansion and upgrade costs. So by preserving that existing wiring, we're reducing a lot of those costs, and we're also reducing a lot of the risk associated with that. The other big area of migration is importing the application program. So we allow you to import the existing program from the original programming software, such as Logic Master, into Prophecy Machine Edition, and the import routine allows you to do that very easily with no problems. We've now upgraded thousands and thousands of projects. We've had no problems with any of those, so we have a very high degree of confidence that you can upload your original program into Machine Edition and then download into the latest generation controller with no problems. And what you do is, to download, there's an upgrade option to upload the application program to PACSystems. This allows you to convert very easily, and again, we've done thousands of these migrations now, so we know there are no issues. So basically, it's very straightforward. Replace your existing hardware, import the application program, upgrade to RX3i, download and run. And what I'm going to do is I'm going to show you how this works in practice with the next set of video. Here I have a Series 9030 running an application. Now GE is renowned for its integrity, but just to show you there is no cheating, I'm going to operate some of the switches on the input simulator, and we'll be able to see that some outputs are activated. So I'm just going to toggle the stop switch into the enabled state. Notice that nothing happens yet, and then I'm going to start the controller by operating the start button. I'm using an input simulator, but in real life this could be coming from a momentary push button. So the start switch would return to the off position. However, the application continues to run. We can also view the operation of the program online using our controller software. In this case, I'm using the DOS-based software, which is called Logic Master 90. And it's a very similar situation for the Series 9070 to RX7i. Here we have a Series 9070 controller. You can see we have the power supply on the left with the central processing unit and the Ethernet interface. And then we have a variety of I/O modules and a Genius bus controller. If we want to upgrade these, we can't use them in an RX3i, but we can convert the program. Alternatively, we could upgrade to an RX7i. The RX7i has the same VME backplane as the Series 9070, although it's now the VME 64 standard, which is faster and gives us a wider memory transfer. But Series 9070 modules are compatible with the RX7i. So we would have to replace the rack, power supply, CPU and Ethernet module, but all the other modules can be reused. So we can just go to our Series 9070, remove the bus controller. Again, if this was installed in a working system, we would just remove the bus controller connections. Same with the I/O modules, just remove the I/O terminations. We can then remove the modules. And here is my RX7i rack. So we have new rack, power supply, CPU, Ethernet module. In this rack we also have a redundancy module as well. So I can now take my Series 9070 modules and install them in the RX7i backplane. And then we just need to migrate the program. So here we have Logic Master. Logic Master 90 runs in a DOS window under Windows 7. Windows 7 isn't actually supported, but it does run quite well. However, it only runs under the 32-bit version of the operating system. I'm actually using 64-bit Windows 7, so I'm running VMware in order to run a 32-bit instance of Windows 7 inside a virtual machine. You can see that the LogicMaster 90 window is fairly small. On older operating systems it was able to run it full screen, but that's something that's not supported under Windows 7. An additional issue is Ethernet communications isn't supported under Windows 7, so I'm using a serial port. That introduces another problem because modern laptops don't have serial ports, so I'm using a USB to serial converter, which brings its own headaches. However, at the moment it seems to be working. So you can see I'm online to my Series 9030 controller. You can see the status lines at the bottom. I'm actually in monitor mode, which means I can monitor what the controller is doing. You can see the controller is running with outputs enabled, and the current scan time is about 2 milliseconds. So if I scroll down a bit, we can see what the program is doing. Here we are viewing online the program, and you can see that currently nothing is happening. So if I remove the emergency stop condition, you can see that power flow is passed by the stop contact because that's become highlighted. And if I press the start button, you can see the run is now enabled and the timer begins to time. You can actually see the current value of the timer underneath the timer just here. Now if I scroll down, you can now see that what I'm doing is I'm just passing the timer current value through some greater than contacts, and when it exceeds a certain constant value it just energizes an output. Here we can see output 17, output 18, and if I continue further down you'll be able to see there are additional outputs to correspond to my relay card that you may be able to hear clicking in the background. So there we are, online monitoring. It's fairly limited. I can only see a small amount of real estate at any one time. If I want to see tables, I can do that by pressing Shift F2 and then choosing the output table I want to see. In this case we can see outputs, or I just had inputs. We can create a mixed table and we can see multiple inputs and outputs at the same time, but it's not possible to view the program and the table simultaneously. Another issue is if I wanted to see where one of these outputs comes from, I can see by moving the cursor over, for example, output 17, I can see that it's actually referenced to %Q17, but I don't know where in the rack that is. So if I wanted to be able to see that, I would have to exit the programming software and then go into the configuration software. So now what I'm going to do is upgrade the LogicMaster 90 application into Machine Edition. Here I'm running VMware Workstation again, and I'm running our Prophecy Machine Edition software. I've created a project called S9030, and currently it has no target. So the first thing I need to do is create my target by right-clicking. I can go Add Target, and I can choose GE Intelligent Platforms Controller Series 9030 PLC. This creates a default target. It doesn't matter what I call it, so I'm just going to call it the default, which is Target 2. So in order then to import the Series 9030 target I was using before from LogicMaster, I just right-click on the target, go down to the Import option, and you can see I can import a VersaPro folder, a LogicMaster folder, or a folder from our control software, which was also called Simplicity Control and Control 90. LogicMaster is the one I want, so I'm going to click LogicMaster folder. I then navigate to my LogicMaster 90 location on my hard disk. The program I was actually using was called CPU 364. And you can see there it's looking for the lmfolder.30 program, which is a file we use to indicate this is a Series 9030 LogicMaster folder. There's also a backup folder there. If you have a backup, you'll have to load it into LogicMaster and restore the backup first, because we can't import the backup. We can only import the actual folder. You can also import Series 9070 targets, in which case you'll be looking for an lmfolder.70 file. So I navigate to my file, I click Open. It warns me I'm about to overwrite my existing project. It's referring to the target. All blocks and variables will be destroyed. Am I sure I want to do this? Yes, because I just created the target, there's no problem there. So now it's importing. You'll notice in the feedback zone we see some information there So I'll just make that a bit bigger so we can see what's going on. You can see there it's got information about what we did. It was able to read the file, it was able to process all of the different memory maps, it was then able to process all of my different blocks. There are a few warnings there to indicate that some files were missing. They are identifier files for some variable types that I wasn't using, so we can ignore those. I don't see any failures, which is good, and I only see those few warnings. And then what you can see is each of the blocks, which is got an extension of .pdt, was successfully processed, and then it was also able to import all of those blocks, including the hardware configuration, and that's it, it's done. So let's just close down the feedback zone, and now you can see the target name is changed to CPU 364. I can check my hardware configuration, and it successfully imported that, a 5-slot rack with CPU 364 input simulator relay modules. And if I go to my logic, we can see the main program together with the calling of each of my subsequent function blocks. Okay, at this stage I'll just remove the inspector out of the way so we can get more screen real estate. This is a nice feature of Machine Edition where you can use the pin buttons to move items out of the way if you're not using them. Another great feature is the companion here, which gives us context-sensitive online help so we can see what we're doing and even click on the question mark button if we want additional information. But a key point here is lots of screen real estate to see what's going on. Currently we're offline to the controller, so what I'm going to do is go online. The way we do that is by clicking the lightning button up here. We're now online and we can monitor what's going on. However, because we've upgraded to Machine Edition, the compiler that Machine Edition uses is different to that that's used by Logic Master. It's all based on opcodes, and there are some upgrades when we go to later version programming software. This would also be an issue for VersaPro or Control. What that means is that when we first import, we get configuration not equal and logic not equal. So the recommendation on importing is to stop the controller and perform a download. So I'm going to go into programmer mode, which is the online mode that we're used to with Logic Master, just a slightly different name. Obviously we're all Windows based now. One nice feature is I've got this multi-tab view. I've also got toolbars and buttons. You'll notice I've got a lot more screen real estate. Actually, I'm only limited by my computer monitor size. Let's stop the controller. I'm going to download and start the controller. It's just rebuilding the program. I'm going to choose to download the logic and hardware. Optionally, I can write items to flash memory, but I don't need to do that. It warns me that storing will overwrite a program stored by another programmer, so it's telling me that Logic Master 90 is going to be overwritten. That's okay. There are 2 warnings there, but I can ignore warnings. It's now compiling and downloading the program. Again, we're using the serial port, so this is rather slow. Normally when we upgrade to RX3i, we would go to Ethernet. We could also go to Ethernet with Machine Edition, because of course now we have a modern programming software that is supported under Windows 7 and will support Ethernet communication, assuming it's all been configured correctly. But I'm still using the same cable that we were using before for Logic Master. I'm going to start the controller. Everything is successful. Close the feedback zone. You can see we've got configuration is equal and logic is equal. And if I start the controller using the stop button first, notice that the highlighting this time is slightly different. We have green highlighting to show that power flow is passed. We can change all these colours, but I prefer to leave the defaults to avoid confusion. So now I'm going to start the application. And there we are, the run contact comes in. My timer is counting. The format for display of the timer current value is slightly different now. I can scroll down, and there we can see the greater than signals. The question mark will be replaced as it gets communication with the controller. Again, we're communicating serially. And notice straight away this time I can see more of the screen. We can also expand the horizontal width of the screen as well by very simply right clicking and going adjust cell width, and I can change the amount of screen space that's being used by the program very quickly just by sliding. So if I want to view tables as we did before, I can now go to my default tables and let's have a look at inputs. And let's have a look at outputs. And I have limited view because it's a fairly small window I'm running here, but here we can see all the inputs. Okay, I'll just toggle a couple of inputs at inputs 15 and 16 so you can see those operating. That's these two inputs here, just to prove I'm not cheating again. These are the outputs, so we'll be able to see those going up in turn. So there are the outputs going from 17 up to 32. And because this is a Windows-based application, if I click my window display here, I can now move all these windows and display multiple windows simultaneously. Again, we're limited by screen space, but we can display as much or as little information as we have available screen space for. And at the very least, having this multi-tab view, we can actually see what's going on very easily. An additional option we have is to go to the navigator and I can see the hardware configuration. So if I wanted to view where the outputs were going, I don't have to exit the program. I can just double click on the output module and I can see straight away that it's Q17 and it's in rack 0 slot 4, which it is. Another option I have here is to view from the program. I can view what are called data watches. So first of all, notice there actually I moved my mouse over something and I get a tooltip. That shows me the current value along with the description. Descriptions were imported, so we can see that there. And I can also see the current value of something. But what I can also do is right click and go to the watch window and I can create a list of variables. So we're variable focused rather than data table focused. So if I want to see several variables at once, for example the timer and the run contact, and maybe I want to see some outputs, I can put all of those down into my variable window here and I can view whatever outputs I need or whatever contacts I need in whatever order I need. So here's how we actually perform the hardware migration. I have my Series 9030 with power supply, CPU, input module and a couple of output modules. And I have my equivalent RX3i. I'm using a 12-slot rack here. I have an AC power supply, a CPU and separate Ethernet module. To swap the I/O, all I need to do is remove the module from the old rack. This uses the Series 9030 connector, which I have available on my RX3i backplane, as well as the PCI connector. So all I need to do is locate my 9030 module in the rack, slot it into place. Now if this was wired I/O, I could keep my existing field wiring, which would be attached to this terminal block, undo the terminal block, move the I/O module and then reattach the terminal block without disturbing any of the field wiring. Job done. So now we've seen the hardware upgrade, let's have a look at how we migrate the software inside Machine Edition. Here's the Machine Edition project we were looking at earlier. I can open up the navigator and we have a CPU 364, and if I scroll over to the inspector you can see currently that's our Series 9030 PLC family. So to upgrade it's very straightforward. I just click in that family box, scroll down to PACSystems RX3i, click, and it warns me, converting from Series 9030 PLC to PACSystems RX3i will result in the removal of unsupported components. Do I wish to continue? Currently those unsupported components include things like sequential function chart blocks and C blocks. So sequential function chart blocks would need to be rewritten. C blocks can simply be recompiled and then re-imported, and they'll be in the 32-bit format that RX3i needs, so that's quite straightforward. So I'm going to say OK to continue. We get a target conversion report that gives us some detailed information about what was converted. This mostly tells us about the hardware. And then at the bottom there we have an analysis of the logic conversion. Logic conversion complete, and it also says there we can store this as an additional file and explore it if we need to. But in this case, no errors, no problems. So now we have an RX3i application. So I'll move over to the navigator, check my hardware configuration, and now we can see we have converted to an RX3i. So the system's automatically changed to an AC power supply, CPU 310, it's added in an Ethernet module, and then it's got my input simulator and my two relay output modules. I actually have a CMU 310, so I just need to right click and replace that module. We'll keep common parameters, so that's very straightforward. At this stage we could choose to change any of the default configuration if we need to, but that should all be fine. And we can also then double click on the Ethernet module, and if we need to, enter in a new IP address and status address, but that's actually imported from my previous configuration, so I shouldn't need to change anything. In fact, provided I use like-for-like components, I wouldn't have needed to do anything at all here. It's just because I've got a slightly different CPU that I needed to make a change. So now I'm going to download my converted program into my RX3i target. First of all, I click the online offline button. Machine Edition then connects to the RX3i. I'm using the serial cable, so this can take a few seconds. I then go to programmer mode, so I'm now online to the controller and able to download. Notice at the bottom right of Machine Edition we're stop disabled, configuration is not equal, and logic is not equal. So to download the controller, I can use the download button or press function key 8. I can then choose what components I want to download. I'm going to choose hardware, configuration, emotion, and the logic. I'm going to leave initial and force values for now, and I'm not going to write all items to flash memory. I'll do that later when I finish testing, and then all my data will be stored in non-volatile memory. So click OK. This builds the application to make sure it can be downloaded, and the feedback zone will display the output of the build process. Any warnings at this stage can be ignored, although they may need attention later, but any errors would prevent the download from occurring, so they would need attention. The build was successful, so now we're downloading all of the slot module configuration, and now we're downloading the program. Remember that because this is an RX3i, this downloads all of the configuration and the program and the documentation. So once downloaded, all I would need to do is upload, and I would have a full copy of all of my folder details, including all of the documentation. So that would be all the variable names, all the run comments, and any related documentation such as Word files, AutoCAD files, Excel files. So uploading from the controller gives me a way of making sure I have the absolute up-to-date latest information without having to rely on backups or files copied from other computers. I'm now downloaded, so I can go to my status window and see that we're in programmer mode still, we're stop disabled, we're configuration equal, and we're logic equal. So at this stage I can put the controller in run mode. The controller is now running. So if I go to my program, there's my logic, here's the main block. If I double click on my manual routine, we can see all of the manual code as we had before. And this is rather slow with serial mode, so I'm going to disconnect from serial mode and connect via Ethernet. So in the navigator, if I select my target and go to the inspector, currently we're selected as communications mode, so I'll just go offline. Go back to my inspector, change the physical port to Ethernet, enter in the correct IP address, and now go back to online mode. And now we're connected via Ethernet. So I'm in monitor mode, run enabled, configuration equal, logic equal. So I'm going to go online now, and then go to my manual routine where I'm seeing my program. So as we did before with the Series 9030, this is my program now running in an RX3i. So I will enable the stop contact, so that's reset any emergency stop signal. Turn on the run contact, and now my system is running. You can see as before, we have the outputs running, we have the timer, we have contacts showing status, and if I move the mouse over anything, we can see the current status. Okay, so really no change from before. Now what I can do is show some additional features, and I have an online cross-reference report that can be very useful for finding things. For example, if I go to my manual routine, if I want to find out whether start contact is used anywhere in the program, I just need to select start, and then in the feedback zone I get an online cross-reference. So you can see there's the normally open contact in rung 2, there's a move word function in rung 2, and there's a normally open contact in rung 3. This is a great way of finding where things are used in the program and navigating through. For example, you can start with an input contact and find out why the corresponding output isn't coming on by searching through the program to find any related interlocks. Or you could do the alternative by starting at an output and then again navigating back through the program to find any interlocks or any other conditions that aren't met for the output not to start. So very good for online cross-referencing and fault finding and commissioning and testing of the application. Here's the final thing we can do. If I go to the Utilities tab, we have a data monitor tool. If I call up the data monitor and go to my variables list, if I want to see a value on there, I can just drag and drop from my variables list and I can bring that in. Let's just bring in the run contact as well. So now you can see we have an online trend. If I start my system again, there's my Boolean contact going up, and there's my timer value going up. So, to sum up, we have the PACSystems RX3i controller using a layered design based on standards with high-performance 32-bit Intel processors and a high-performance PCI backplane, but including a serial backplane for forward migration from older applications. Additional features include symbolic programming, object-oriented programming, the facility to store the program and documentation in the controller, and the platform for all future development. Migration is very straightforward. We just replace the existing Series 9030 rack power supply and CPU with a new rack power supply and CPU, but we reduce our costs and our risk by keeping existing I/O modules and field wiring, and by importing and migrating the application from the Series 9030 to the PACSystems RX3i family with a very straightforward upgrade process that you've just seen. So, very straightforward, very low risk, and a great platform to be moving forward with.